Hi, welcome to Teacher 1-in-1's channel. Today, we will discuss gravitational potential energy and kinetic energy, under work and energy. The most essential competency of this lesson is to identify and explain the factors that affect potential and kinetic energy. But before that, let us recall the last topic, which was about Newton's 3 laws of motion by Sir Isaac Newton. You are going to state each law of motion. Let us start with the first law of motion, or the law of inertia. You can type your answer in the comment section. Correct. It states that a body at rest remains at rest, or, if in motion, remains in motion at a constant velocity, unless acted on by a net external force. Next, please state the second law of motion, or the law of acceleration. You can type your answer in the comment section. Very good. It states that the acceleration of a system is directly proportional to, and in the same direction as the net external force acting on the system, and inversely proportional to its mass. And the third law of motion is the law of interaction. Please state what is this law. You can type your answer in the comment section. Great job! It states that, for every action, there is an equal and opposite reaction. Now that you are ready to move to the next lesson, I will give to you the learning objectives of our lesson. Number 1. Define gravitational potential energy and kinetic energy. Number 2. Determine the factors that affect gravitational potential energy and kinetic energy of an object. Number 3. Calculate gravitational potential energy and kinetic energy of an object. And number 4. Differentiate gravitational potential energy from kinetic energy of an object. Let us define the word energy. Energy is the ability to cause change and capacity for doing work. There are different forms of energy, but they fall in these two basic categories, which are potential energy and kinetic energy. Potential energy is stored energy and the energy of position, while kinetic energy is the motion of waves, electrons, atoms, molecules, substances, and objects. The forms of potential energy are elastic potential energy, electrical, electromagnetic potential energy, nuclear potential energy, and gravitational potential energy. For kinetic energy, the forms are electrical energy, or electricity, light energy, or radiant energy, thermal energy, and sound energy. These forms of energy we'll discuss in separate video lessons. Let us discuss first about gravitational potential energy. It is a potential energy due to elevated positions. Imagine a bowling ball is sitting on a table. It has gravitational potential energy as it sits on the table, because it has the ability to cause change. What happens if the bowling ball falls off the table? Gravitational potential energy changes to kinetic energy. Let us determine the factors that can affect the gravitational potential energy of an object. What happens to the gravitational potential energy of the bowling ball if the table is higher? The gravitational potential energy of an object is greater if the position of the object is higher. The object has the potential to cause more change. How does mass affect the gravitational potential energy of an object? We have bowling ball and volleyball. The more mass an object has, the more potential energy it has, because it has the potential to cause more change. Here are the basic concepts of gravitational potential energy. Gravitational potential energy is stored energy due to its elevated position. Gravitational potential energy is greater if the position of an object is higher, and gravitational potential energy increases as the mass of an object increases. Now, let us define kinetic energy. Kinetic energy is the energy an object has due to its motion. If an object isn't moving, it doesn't have kinetic energy. It came from the Greek word kinetikos, meaning putting in motion. Let's use the bowling ball as an example. If you roll the bowling ball, it moves faster. What happens when it hits the pins? A faster ball causes more change to occur than a ball that is moving slowly. Remember, kinetic energy increases as an object moves faster. Suppose you roll a volleyball down the alley instead of a bowling ball. If the volleyball travels at the same speed as a bowling ball, do you think it will send pins flying as far? An important difference between the volleyball and the bowling ball is that the volleyball has less mass. Even though the volleyball is moving at the same speed, it has less kinetic energy because it has less mass. Remember, kinetic energy increases as the mass of an object increases. Here are the basic concepts of kinetic energy. Kinetic energy is the energy of motion. Kinetic energy increases as an object moves faster, and kinetic energy increases as the mass of an object increases. Let us identify how to calculate gravitational potential energy and kinetic energy of an object. How to calculate gravitational potential energy. From the factors that can affect the gravitational potential energy, it can be calculated through this formula or equation. P sub g is equal to m times g times h, wherein P sub g is gravitational potential energy with a unit of joule, m is mass with a unit of kilogram, g, which is the acceleration due to gravity, with the constant value of 9.8 meter per second squared. Since the gravitational potential energy is energy possessed by an object elevated above the Earth's surface, it is necessary to involve this factor, nh, which is height with a unit of meter. Have you noticed these two factors? It has something to do with the free fall, right? You can recall it in the topic under the law of acceleration. If we multiply mass and acceleration due to gravity, we can get the value of weight with the unit of Newton. So, we can use this formula in getting the gravitational potential energy of an object. Let us have a sample word problem about gravitational potential energy. There is a bell at the top of a tower that is 45 meters high and weighs 190 newtons. What is the gravitational potential energy of the bell? To answer this word problem, let us have the steps on how to solve a word problem. First, read and analyze the problem. Second, identify the given with their corresponding unit. Third, find the appropriate formula or equation. Fourth, solve the problem by substituting the given value to the formula or equation. And fifth, state the final answer with correct unit. Go back to the problem. The first thing we should do is to read and analyze the problem. Let us read again the problem. There is a bell at the top of a tower that is 45 meters high and weighs 190 newtons. What is the gravitational potential energy of the bell? After reading and analyzing the problem, what we should do next? Correct. Identify the given. What are the given? The given are height, which is 45 meters, and weight, which is 190 newtons. After identifying the given, what is next? Very good. Find the appropriate formula or equation. Since we need to get the gravitational potential energy of the bell, we are going to use P sub g equals to weight times height. Now that we have the formula or equation, what we need to do next? That's right. We can now solve the problem. We just need to substitute the value of weight, which is 190 newtons, and height of 45 meters to the formula. So, we can have P sub g equals to 190 newtons times 45 meters. The answer is 8,550 Newton meter. Is this the final answer? Correct. It is not yet the final answer. Why? Because the unit of gravitational potential energy should be in joule. Therefore, we need to change Newton meter to joules. So, the final answer is, the gravitational potential energy of the bell at the top of the tower is 8,550 joules. Now, it's your turn to solve a word problem about gravitational potential energy. Here is the problem. There is a rock near the cliff that is 150 meters high and has an estimated mass of 120 kilograms. What is the gravitational potential energy of the rock? The acceleration due to gravity is 9.8 meters per second squared. You need to show the following given formula, solution, and final answer. You can type your answers in the comment section, or you can write it in your paper. I will give you 1 minute and 30 seconds to do this. Time is up. Let us identify the given with their corresponding unit. Height, which is 150 meters, mass of 120 kilograms, and the acceleration due to gravity, 9.8 meters per second squared. Did you get them? Very good. For the formula, we have P sub G is equal to M times G times H. Did you get that also? Wow. And for the solution, we are going to substitute the values of the given to the formula. From that, we come with the answer, 176,400 kilogram meter squared per second squared. Question, is this the final answer? Of course not. Because the unit in the answer is not in joule, so let us change that to joules, since it is the appropriate unit for gravitational potential energy. So, the final answer is, the gravitational potential energy of the rock is 176,400 joules. Did you get it right? Amazing. Now let us try to calculate kinetic energy of an object. Since the factors that can affect the kinetic energy of an object are mass and velocity, we can calculate it through Ke equals 1/2 m times v squared. Wherein Ke is the kinetic energy with the unit of joule, m for mass with the unit of kilogram, and v for velocity with the unit of meter per second. Let us try this sample problem. First, read and analyze the problem. An 80 kilogram man is jogging at a rate of 4 meters per second. What is the kinetic energy of the man? Now, let us identify the given. The given are, mass which is 80 kilograms, and velocity 4 meters per second. The rate is referring to the velocity, and if you notice the unit is meter per second, which is the unit for velocity. After this, let us find the appropriate formula. Since we need to identify the kinetic energy, we will use the formula Ke equals to 1/2 m times v squared. Now, we can solve the problem by substituting the given value to the formula. Multiply 1/2 and 80 kilograms, the answer will be 40 kilograms. Square the velocity, 4 meters per second, the result will be 16 meters squared per second squared. multiply 40 kilograms to 16 meters squared per second squared. The product will be 640 kilogram meters squared per second squared. Is this the final answer? Correct. It is not yet the final answer, because the unit of the final answer must be in joule. So, we need to change it to joules. Take note that 1 kilogram meter squared over second squared is equal to 1 joule, and 1 Newton meter is equal also to 1 joule. It is now your turn to calculate the kinetic energy of an object. A car is traveling with a velocity of 40 meters per second, and it has a mass of 1,120 kilograms. What is the kinetic energy of the car? Show the following, given, formula, solution, and final answer. You can type your answer in the comment section, or you can write your answer in your paper. I will give you 1 minute and 30
seconds to answer this.
Time is up. The given are, velocity of 40 meters per second, and mass of 1,120 kilograms. Did you get it right? Great job! For the formula, Ke is equal to 1/2 of mass times velocity squared. Did you get that also? Amazing! For the solution, just substitute the given values to the formula. Then solve for it. The result is 896,000 kilogram meters squared per second squared. Did you get that? You did great. And for the final answer, the kinetic energy of the man is 896,000 joules. Did you get that? Wow! You are amazing. Based on what we discuss, let us differentiate gravitational potential energy and kinetic energy. Gravitational potential energy is stored energy due to its elevated position, while kinetic energy is the energy of motion. Gravitational potential energy is greater if the position of an object is higher. Kinetic energy increases as an object moves faster. They both increases as the mass of an object increases. To calculate gravitational potential energy, multiply mass, acceleration due to gravity, and height of an object above the Earth's surface. To calculate kinetic energy, multiply the half of mass, and the square of velocity. Let us check your understanding. Are you ready? Alright. You are going to choose the letter of the correct answer. Type your answer in the comment box. You have 10 seconds to choose and type your answer. Number 1. Which of the following has a standard unit of joule? A. Energy, B. Gravity, C. Height, or D. Power? If your answer is A. Energy, you are correct. Number 2. What is stored in an object that is lifted above the ground? A. Gravitational potential energy, B. Height, C. Kinetic energy, or D. Velocity? If your answer is A, gravitational potential energy, you are correct. Number 3, which of the following factors can influence the gravitational potential energy gained by an object? A, acceleration and speed, B, height and velocity, C, mass and height, or D, speed and gravity. If your answer is C, mass and height, you are correct. Number 4, which is the correct equation to calculate the kinetic energy of an object? If your answer is A, you are correct. And for last number, what is the GPE of a ball with a mass of 4 kilograms lifted 5 meters above the ground? A, 20 joules, B, 96 joules, C, 169 joules, or D, 196 joules. If your answer is D, 196 joules, you are correct. How many correct answers did you get? If you get lower than 3, don't worry, you may rewatch and study again this topic. This is the summary of the lesson. I hope you learned a lot from this lesson. If you have questions, you may leave them in the comment section, and I will surely answer that. See you in the next lesson. Please follow us in our FB page, and please click like, the subscribe button, and the notification bell for more upcoming videos. Thank you so much and God bless.